Okay, so in this video, I'm starting a new series in which I'm trying to create a C++ library which would help the user who are creating chess engines. Okay, so the library would include like some move generation functions, how to represent a board, and like we could update the board, we could import a PNG and it would just create a game, and it would also return us some parameters like material balance and like other stuffs, which would be very helpful in creating an evaluation function and doing machine learning. So like this is basically a type of copy of Python's chess library, or in JavaScript, the chess library. Yeah, there's a chess library in JavaScript, like something similar to that. Okay, so if you click in this video, I assume that uh, in past you have tried to create a chess engine by yourself, or if you don't, like just pause the video and try to think how could you like create a chess engine, what should be the logic. So the like most common or most simple logic to create a chess engine is, first of all, the board representation would be an int array of 64, which is fine. Like the array could be of 64 integer or 8 by 8 integer or a bit board, or yeah, these three things are fine. But like it's very simple, like the empty square would be assign a value of 0, pawn would be assigned 1, knight equals to 2, bishop 3, rook 5, queen 9, and king 100. Like this is very basic. And if it's white, then the values would be positive. If it's black pieces, the value would be negative. And like because the board is like very simple, so the move generation function would be like very complex. So like as you can see in move generation, first we have to iterate the entire board. Like this is then int array of 64. So we have to first iterate over all the 64 squares. And then we have to check if the piece is of the right turn. Like if it's right turn, so the piece is greater than 0. The value of that index is greater than 0 or not. If it is greater than 0, then we have to run a particular function for that piece. Like if the let's say board, like board is an array, board bracket 3, which means third index of that board is equals to bishop. If it's a bishop, then we have to run a particular function which will return bishop's like square of an index. And after that, we have to do that for every piece, for every move. Like we have to do that for all the 64 cells, and then I mean all the 64 squares. Then every move we have to do the same. So like it's very complex. Like if I have to tell what's the time complexity of this, that would be like n cube, I guess. Wait a minute. Mm, First we have to like that. Then yeah, it's n square actually. It's n square. So like that's very slow. And let's say we have to create a check or checkmate function, because these are also very important function in an chess engine. To check if there's a check on a king, first we need to find the index in which the king is. Like we have to iterate towards all the 64 boards, and if the value equals to king, which is 100, then we have to run all the uh, like all the different pieces move generation, giving the parameter the king's index. So like the king would act as a queen, a rook, a bishop, a knight, and a pawn. And if we could see an enemy piece of the same kind, then it's a check. Okay, like let me explain this in a board editor. So let's say we have a king here on e2, and let's say we have a rook here. So currently it's not a check. Okay, so first it will iterate to a1, b1, then like when it reached the e2, then it would like king would act as a rook. So it could see this square, and these all are empty, so it's not a check by a rook. Then it would act as a bishop, like so it could see all these squares, and if in these squares a bishop is there, currently it's a rook, so it's not a check, but if a bishop or a queen is there, then it's in like check. So if it is this, then it's a check. Okay, so we have to do this for like a knight too, like if there's a knight, the king would act as a knight, and like it's very, very, not very good, like it's very slow, and we have to do this in every turn. Okay, so like after like I have actually created 7 different chess engines using these like very simple board representation and move generation and checks like this, and they are very slow, and there are a lot of bugs in that because the functions, let's say the function which will return possible moves, it's a very large function, and there are very, a lot of bugs. So instead, uh, I thought about like this is my way. Okay, so in this the board representation going to be very complex, but because the board representation is very complex, move generation and checks would be like very simple. So it would be very fast because these values are constants, so like it's very fast. Okay, so the board representation would be an int array of 64. You could take it as an 8 by 8 array or a bit board. All three of those are fine. So value of each index would be an piece ID. So in this, the value would be the value of that piece, that the value of a pawn is 1, the knight is 2, but in this it would be an piece ID. What do I mean by that is, let's say starting position. Okay, so if we consider the first case, the first board, the value for like this pawn and this pawn would be same, and this pawn would be same. The value for this knight, this bishop, and this bishop would be same. But if we are talking about this one, the value of this pawn and this pawn would be different. It's not actually value, it's actually a piece ID, which would be unique for all these 32 pieces. So this is unique. This would have an unique ID. This would have a unique ID. Similarly, this would have a unique ID, and like you get the point. So what's the benefit of doing that? So these are a lot of points. We will discuss that later. So there would be a map where key would be a piece ID and value would be an structure of piece type, piece index, and piece vision. What do I mean by that is, let me open a text file. So this is the file that I created for a project. Here I'm going to, first write in documentation. So like documentation, and that I'm going to create, and let me first open this in Visual Code. That would be like very good. Open in code. Now here, delete this one. Yep. Create new. I'm calling it temp dot. Yeah, this is a temporary file. I'm going to change the documentation later. Dot md. Okay. So what I'm saying is, I hope everything is visible if I do this like, yeah, it should be. So what was it? There would be a map where key would be a piece ID and the value would be a structure of piece type, piece index, and piece vision. Okay. So first of all, there are 32 squares in a board. So the max limit of that map would be 32. But for like more simplified structure, I'm going to create 2 maps. First would be white pieces, which would be an int of size, not an int, sorry, not an int. It's going to be a structure of size 32. And similarly, black pieces of size 32. Now you may wonder, like the maximum pieces that fight could have is 16. So why did I put 32? So the reason is, if I like the index would be your ID. The index is a piece ID. So like if I write white pieces, I'm basically iterating equals to 2. So I am trying to get the data of piece ID 2. But if I like do the same thing like black pieces and the same thing. So like I said in my first point, the piece ID would be unique for every piece, no matter what the color is. Okay, so it can't be 2. Okay, so it can't be 2. So it has to be like 1, 0, 3, 4, or 31, like any number, but it can't be 2. Okay, so there's going to be like very empty space in a map, but iterating towards it, like it's very fast. It's in constant speed, and it's like not a very big deal, not a very big memory. So we would do it like this. And a piece type, so the struct it would be a structure. So let me just write, it's going to be a structure. Okay, similarly, like copy this. Ah, come on, come on. Okay, the structure would be like, so let me just explain. The structure would be your uh piece type. Okay, piece type, piece index, piece index, and piece vision. Okay, so piece type would be like empty, pawn, like similarly, like is it a king, is it a queen, like that. Okay, I'm going to represent it by an int, so we'll do that later. But the main thing, it's going to be like empty, pawn, knight, bishop, rook, queen. Okay, okay. Then next is a piece index. So like in which index the piece is currently. Okay, so if we represent a board by an 64 int array, so like this square, this pawn would be it's an E2, but like 0 to 7, 8, 9, 10, 11, 12. It would have an index of 12. Piece type would be pawn. Okay, and piece vision. So like piece vision is going to be a vector inside a vector of int. So it's going to be a vector inside a vector with a data type of int. So like if you are new to C++ programming language, I highly recommend you like learn what a vector is. To like simply put it, a vector is like an array, but you could like expand it. Like let's say a vector is let a be a vector of data type int. Like here you could write data type. It could be an int, it could be a string, it could be anything else. So I'm going to write int, and to expand it, I'm going to write a dot pushback, a dot push back, and I'm going to write like 1, 2, like whatever. So it doesn't have a constant like size. It's a variable size. Okay, and we don't know how many like how many squares that a piece can see. So the next point is, let me just create a vector inside a vector. Okay, I know it's a little bit boring, but stick with me, it's worth it. Yeah, I think it's fine. Okay, so the first vector, like here, let's assume it's a bishop. Like a bishop would be a better example for now. So let me just write it a bishop, bishop. Okay, and you know what, let's just clear this board. And yeah, bishop is here. Okay, I am not going to like a main focus is piece vision. So this bishop could see these four diagonals, right? These four diagonals. And I want each diagonal to represent a vector. I'm going to like explain what's the benefit of doing that instead of like just writing one vector. Like there's a difference. So let's just write. So these would include piece IDs, you know. So if it's an empty, then we would like figure something out like it's an empty or not. But let's say there's a pawn here. So these two are empty. So empty, comma, empty, empty. Then there's going to be a pawn ID, black pawn ID, black pawn ID, and then there's an empty. Okay. So what's the benefit of doing this? So let's say this pawn ever moves. So we don't have to like the, let's say, another pieces. Okay. Let's assume this is a board. There has to be like a king and an opponent king. So let's assume if this pawn moves, because this pawn is in the vision of bishop, of this white bishop. So we would only update these bishops vision, and the king and queen and rook vision would be like constant. We would not update those. But if like it's a standard like board representation, we have to iterate towards all the pieces, and we have to like first update this rook, and this rook is not changing because this pawn is not affecting this rook. It is only affecting this bishop. So like I think you get the point what I'm trying to say. So if ever this pawn ID will move, this bishop's moves would be affected. Okay. Similarly, we have to do this for this diagonal, and this diagonal. And now a main question. If I like represented like in one vector, then like there's a thing that check. Okay. So let's say instead of empty, there's a king. So if it's black move, we could see if this pawn move ever moves, white bishop could see this because there's a pawn above the king. Okay, and all the pieces are empty. So which means we could write a very simple logic that ever this pawn moves, there will be a check on king. So like it's very easy. Or and if it's like the standard board representation, we have to go deep down. We have to like write and separate engine. It's like if we ever move this pawn, we have to if we ever move this pawn, like I'm explaining, if a border is represented like this. So let's say it's black move, and first black engine is calculating moving this pawn like this. So first it would like calculate all these rook moves and check if black king is in check. Then it's going to do the same thing with the queen, with the king, and then it's gonna come to the bishop. And if we see the bishop is checking the king, then we could say that this move is illegal. Like this is very slow, like very complicated. But if we represent it like this, we could like easily see that there's an empty, there's an black pawn ID, then there's a king. So it's obvious that if ever this black pawn changes, there will be a check in king. Like very simple. Okay. We don't need a for loop or if else. I mean, we need an if else, but we do not need an for loop. Okay. And now let me explain what happens with this. So let's just explain there's a knight over here too. Okay. So if we write it in one vector, which would be like, first of all, let me just write here empty, my bad, empty. Then there's a knight, black knight. Oh, come on. Black knight, then there's going to be an empty. Okay. I'm sorry for my bad typing. And now if we like write it in one vector, there's going to be like a black pawn. We could like only write it like this: a black pawn, then a king, then a knight. Okay. So in this case, if the knight moves, if we are using this vector, so we could easily see that if the knight moves, then nothing. There's no king. Okay. If the knight moves, then we just update this bishop's vision. Nothing else. Because there's not a king in this vector, but there's a king in this vector. Okay. But if we represent our piece vision in one vector, if this knight move, we see there's a king, but the king is not affected by this knight. So I think you get the idea why we need like a 2D vector. Okay. So I think that explains a lot because it's kind of complicated. These things are kind of complicated. And these are the main like source why this, it's very fast. Why this method is very fast. So it's worth explaining. Okay, is there anything else? Piece vision would be also contain the pieces which are blocking the piece path. So when those pieces were moved, we would update only the piece, yeah, thing that I just explained. Now let's come to the move generation. Iterate in the map, use the piece vision. Update the piece that are linked to the piece that we want to move. That is it. So our move generation would be a lot faster. Yeah, the thing I just explained, that if this knight move, then this knight is connected with this bishop, so this bishop would get updated. Okay, not these pieces, because these pieces are not linked with this knight. Okay, only this bishop would get updated. Now check and checkmate. The vision in piece object would also store what other piece can. Yeah, same thing that I just explained, that this pawn cannot move because of these reasons that I just explained. Okay. Other benefits of representing a board like this is, with all these data, we could create a effective and fast evaluation function, and also we could use these parameters in a machine learning model. Like if we represent a board like this, we have lot of parameters. You know, while creating a machine learning model, we need lot of parameters, and if we want to create an effective like chess engine, like machine learning chess engine, we seriously need a lot of parameters. I actually tried to create a machine learning AI chess engine with using this board representation, and it was horrible. Like there were no improvement, the machine learning model just stuck in a loop, and like it's a waste of time. But I think if I represent the board like this, it's going to be better. I did not do it, but we will do it in future. Okay, because we have lots of parameters. Okay, so I think I explained what the basic board representation would be. Now let's just write some code. Okay, if you do not understand, like if you do not clearly understand what I was trying to say, it's fine. Now we are going to write code and you will understand that. Okay, save, create another folder, src. There would be a source code, and let's just create another folder with tests. We would run our test subjects in this, and let's just create an yeah, I think it's fine. So in src, let's create another folder that we would call it board. Now in that we would create another file which would be board.hpp. Sorry. Okay, board.hpp. I think I should zoom in a little. Is it too much? I don't know. Let's just stick with it. So first thing first, hashtag include vector. Okay, hashtag include vector. We would use vector in this. Now let us create a class name board. Okay, so our board would be a class. First, it would be like an int board 64, not 65, 64. Okay, let me just open my wait a second. Yep, int array of 64, we created that. Okay, now to create a chessboard we need other stuff as well. like a bowl of castle, bowl castle 4. Okay, so what this would include is the castle index 0 would be like if the king has castle. Let me just write that in an documentation file, you know, create a new file, name board. Yeah, board would be fine. My bad. Let me just add some board.md. Come on, I'm sorry. Board.md, yeah. Board.md, then class board. So hashtag board here. Variable would be castle. So we would discuss the castle variable. So like 3 castle of 4 bool. It's in boolean type. Okay, right? Yeah. This would, you know, include castling rights. What do I mean by that is index 0 if white can castle king's side. And let me just control plus delete 3 times. Yeah, now this would be index 1, index 2, index 3. If white can castle king, no. If white can castle queen side. If black can castle queen side, control plus C, control plus V, queen. Yeah. So index 0 of this castle would include if white can castle king side. You get the point. Index 3 would include if black can castle queen side. Yeah. What does this mean is, let's just go to a board. Okay. Starting position. So here white can castle both king side and queen side. Similarly with black, black can also castle king side and queen side. Now you may wonder, like, there's a knight and bishop like blocking. We do not need this. Like, okay, we would evaluate like sometimes later. Like here it can castle, but let's say a king would move there and it comes back. Now technically it can castle, but these parameter would just be false, so it cannot castle. Like, you get the idea, if it's allowed or not allowed. Castle is allowed or not allowed. So currently it's not allowed. Like, okay, currently it is allowed, but after we move a king it would not be allowed. Okay, so that's why it's in bold type. Okay, now what the hell. Yeah, so that's it. Wait a minute, let's expand it. Control plus save. Now we have castle. We also need an int n percent. So everyone knows what an in percent is. If you don't, like, learn some chess rule. It's important for this project. Now we have board, we have castle, we have in percent. What else we need? We need an float. Float 50 moves. Float 50 moves. So there's a 50 move rule in chess, which means like, if a pawn, or if for 50 moves there's no pawn moves and there's no capture, then the game would be draw. Okay, and why did I include float? Because I said 50 moves, not 50 plies. So for, like, if this is white moves, then let its value equals to 0. Then after white this black move, then it would be 0.5. Okay, then if it against white move, then it's going to be 1, because in that cycle one move is completed. Okay, so I think you get the point why its data type is float. Okay, we have 50 moves, and what else do we need to represent a chessboard? Board, castle, and pass in 50 moves. Anything else? Anything else? Mm, I'm not remembering anything else. So yeah, the thing I just discussed here. What was it? There would be a there would be a map, actually an hash map. So it would be a, you know, it's an int or yeah. So we need to create a structure. Struct piece. Struct piece. Okay. So it's the structure that I just explained here. Where's the temp? Yeah, this structure. We are creating this structure. Okay. So let's just come to a file. So like I explained it, I just forgot. It's gonna have a piece type, a piece index. Okay, piece type and piece index. So for piece type, I'm going to create another class. That would be an enum class. Okay, enum class piece type. Okay, enum class piece type. So if you don't know about the enum class, let me just explain it. So we're just going to write empty. You know what? Let's just use capital letters for this. Empty, empty, pawn, knight, bishop, bishop, rook, queen, king. So what does that do is it automatically assign a value equals to 0 to empty. You see, empty equals to 0, pawn equals to 1, knight equals to 2, bishop equals to 3, rook equals to 4. Like it's a very readable syntax. It's a good way of writing a code. Okay, so struct piece, we are going to have piece type, piece type, piece type, piece type, piece type, piece type. Okay, I know the naming convention are not too good, but deal with it. Now we are going to have an int index. It was stored on what index a piece is placed. Next would be our piece vision, which I just explained. It's going to be an vector. So we are going to write std vector, and it's going to be an int. So basically it's an two-dimensional array. That's all, which is expandable. Okay, vector int. What should I name it? I should name it vision. Okay, vision. I just explained, so I'm not going to explain it once again. So now we have struct piece as well. Now just we are going to write piece, white piece, white pieces, which would be a array of 32. So white have 32 pieces. Now just do the same thing. Now here's a black pieces. Okay, black pieces. Do I need something else? Uh, you know what? Let's just create an int material balance. Should I create it or not? You know what? Let's just create it. Material balance. Okay. Do I need something else? Let's just see. Structure, piece, vision. Yeah, for now, this much is enough. If I need, I will add another parameters later down the series. But for now, these are a parameter. Oh, you know what? I remember something. Yeah, now I remember. It's going to be an std string fen. Fen is like very important, very important. It is not identifying string. You know what? Let's just add string, because we are going to use the by default functions of string library. Hashtag include string. Yeah, hashtag include string. Okay, perfect. Now we are going to create some public functions. So just public, by default these parameters are private. Okay, by default. So public functions would be our, yeah, first would be our constructor. So that would be board. It would accept a std string fen, and fen's default value would be, let me just copy the starting position fen. So this is starting position, just copy this fen and now just paste it here. Like this would be a fen's default value. We could change this later. So here would be some code to convert fen string to the above parameters or members. Okay, we are going to write it later. Now second function would be you know what, move generation. I think move generation, yeah. Later another function would be a void move generation. Should it be void? No, it, for now let's just consider it a void move generation, void move generation. And now bracket close. That's it. It's going to uh, return all possible moves. Yeah, we have board, we have move generation, we also need a void update. It's going to update our board. Okay, update our board or update our pieces. We are going to like thought about it later. So update would be you know some code to update the board. Yeah, so that's a structure. You know what, let me just create a test file too. Test file would be board.cpp. It would include hashtag, no, this is not a hashtag include src source board.hpp. Yeah, wait, it's going to be a like these brackets. Okay, what the fuck, wait a minute. Yeah, perfect. Now let's just create an int main and we would run some tests to check if this header file is working properly or not. So I think, yeah, that's it for the today's video. In the next video we would like create these functions. Yeah, and in the later in the series we would also create a chess engine using this library which we are creating. Yeah, that's a lot of fun. So that's all for the today's video.